So 2.1, we are given a sigma notation, and this says that the sum, or this pattern rather, is starting off from the second term and going up to the 13th term. So remember that whenever you have a sigma notation, it is extremely important that you analyze what you are given. Remember that the number at the bottom tells you the term that you are starting off with, which isn't always 1. So here we're starting with term 2, and it goes up to the 13th term. And on the right hand side of the sigma sign, you will find your general term. Just by looking at this general term, we can clearly see that it is geometric. And how we know this is because the variable is an exponent. So we've got negative 3 to the power k. Now 2.1.1 says write down the values of the first 3 terms of the series. So generally, when it comes to the first 3 terms, I know that you will think of term 1, term 2, and term 3, but do not make that mistake for sigma notation. The first 3 terms will always be from the starting term. Here the starting term is 2, meaning that the first 3 terms would be term 2, term 3, and term 4. So that is something that is extremely important for you to take note of. It would be the first 3 terms from the starting term. So this is going to be negative 3 all squared, which will give you 9. Then we're going to have negative 3 all cubed. That is going to be negative 27. And then negative 3 to the power 4. That is going to be a positive 81. So those are the first 3 terms. Then 2.1.2 says write down the value of the constant ratio. Now we know that to get the constant ratio, generally we can take term 3 over term 2 or term 2 over term 1. Basically, it is the ratio between any 2 consecutive terms. To calculate this, I will go with term 3 over term 2. So I've got negative 27 over 9. And that is going to simplify to negative 3. So my constant ratio here is negative 3. Now for 2.1.3, they ask you, will this sum, and notice what they've done, okay? They have replaced the 13 at the top with infinity. So what they've done is they've tried to create a sum to infinity out of it. And they ask you, if we have to take this as a sum to infinity, will it converge? And explain your answer. Now you guys, it is extremely important for you to take note that for a series to converge, R must lie between negative 1 and positive 1. So if we analyze the value that we had for R, our constant ratio in the previous question was negative 3. Clearly, negative 3 does not lie between negative 1 and positive 1. So for that reason, this series will not converge. Now because it's 2 marks, we're going to get 1 mark for saying no and 1 mark for explaining why. So let's write this out properly. We'll start off by saying no, and the next thing we're going to say is that R does not lie between negative 1 and positive 1, and that is sufficient for you to get the 2 marks. If you want to expand on this, you can say, since R is equal to negative 3. So R does not lie between negative 1 and positive 1, since R is equal to negative 3. So that way you feel like you are not leaving out the value of R. Okay, let's go on. Then we have 2.1.4, and if you notice what they've done here now is that they've given you this same sigma sum from before, but now they have multiplied it by x. Okay, so they've got that being multiplied by x, and they ask you to calculate. Now generally, if you have a sigma question, a sigma sum, and they ask you to calculate, you usually get a value as your answer. But since this entire sigma sum is being multiplied by x, it means that we need to give our answer in terms of x, and this is extremely important terminology. In maths, whenever they ask you to give a question in terms, give an answer in terms of x, it means that x must be in your answer. For example, if you would have 50, your answer would now be 50x, that sort of thing, okay? Where in this case, whatever the answer was going to be for this sigma notation, it is now multiplied by x. So all we have to really do here is get the answer for the sigma notation and then multiply by x. Alternatively, you can include x in all three terms, substitute x into your formula and get your answer in terms of x. So either method is fine. Okay, so I'm just going to work with this, including x in every step. Now, you guys remember that when it comes to working with these sigma notation questions, there is specific steps that we use. And generally our steps are, we're going to calculate the first three terms from the starting term. So our starting term is 2, so we would get term 2, term 3, and term 4. However, remember that we have already calculated those terms in 2.1.1. But what is different now is that those terms are going to be multiplied by x, because the entire sigma notation is being multiplied by x, meaning that the first term is now going to be 9x, actually the second term, right? The third term is going to be negative 27x, and the fourth term is going to be 81x. Since this is geometric, we are looking for a, r, and n. Now a is always the first term that you calculated. R, we had already gotten that, it was negative 3. And remember, n is always the top value minus the bottom value plus 1. So that always works that way. Top value minus bottom value plus 1. So n is going to be 12. Now you guys remember that when it comes to calculating the sum for a geometric series, there are two separate formulas. There's a formula that we use when n is greater than 1, and another formula when n is less than 1. Actually, when r is less than 1. So here, r is less than 1 because we have negative 3. So we're actually using the second formula, which is a into 1 minus r to the power n over 1 minus r. And we are calculating S12, where a is 9x, 1 minus r is negative 3. It's going to be to the power 12, all over 1 minus negative 3. Now, here's how I am going to simplify. We can actually put the entire thing on the calculator, obviously leaving x out of it. And that is going to give you negative 1195740. And we're going to have x next to that, since this was being multiplied by x. So that would be the final answer. Okay, let's go on to 2.2. It says a quadratic sequence with a general term Tn has the following properties. Term 29 is 1166, and Tn minus 1 is 3n minus 4. Okay, firstly, two extremely important bits of information that is going to allow us to solve this. Now, firstly, term 29 is 1166. That is for the quadratic pattern itself. Okay. However, this 3n minus 4, Tn minus 1, what does that mean? That is referring to the first differences. And we know that the first differences is arithmetic. Now, since we have the general term for those first differences, that actually allows us to calculate the first few terms of the first difference. And that is a huge step towards calculating the general term of the quadratic pattern. But the question itself says determine the value of the first term of the quadratic sequence. So here is the aim. The aim is to get Tn is equal to an squared plus bn plus c, meaning that we are trying to get the general term of this quadratic pattern. Once we have the general term, then we can answer the question and get term 1. So right now we're going to use these two pieces of information to try and get the general term and thereafter get term 1 based on that. Okay, so here it is. I've just tried to sort out the 3 different rows that we have for quadratic. We know that the first row represents the quadratic pattern itself, and then our first differences would be arithmetic, and from there we can get our second difference. Also, let's just fill in that for the first difference we were given Tn as 3n minus 4. So what this does is, since we have the general term for the first difference, that will allow us to calculate as many terms as we need in the first difference. I've just allocated space for the first 3. Okay, so if I substitute 1 in here, my first term would be negative 1. If I substitute 2, second term would be 2. If I substitute 3 in here, so that would be 6 minus if I substitute 2, it would be 6 minus 4, which gives you 2. That's correct. If I substitute 3, it would be 9 minus 4, which gives you 5. So we now have the first 3 terms in the first difference. And we can use those to get the second difference. We notice that from negative 1 to 2, we are adding 3. 2 to 5, we are adding 3. So the second difference, which is constant, is just 3 throughout. Now, remember that when you are calculating the general term for quadratic, we generally work from the bottom up, and we take the first term in our second difference and equate it to 2a. We take the first term in the first difference and equate that to 3a plus b. And we take the first term in the quadratic, which right now is unknown, but we would equate that to a plus b plus c. Okay, so we always work from the bottom up. So starting off here, we are going to have 2a is equal to 3, and solving for a, we have a as 3 over 2. Next, we're going to go one step above, so we have 3a plus b, where a is 3 over 2, plus b is equal to negative 1. That gives you 9 over 2, plus b is equal to negative 1. Taking the 9 over 2 over to the right, it is going to subtract, and that gives you negative 11 over 2. Now, the next step where we may encounter a problem is that in order for you to solve for c, you cannot just work with a plus b plus c because we don't know what the first term is. So we don't actually have something to equate it to. But using what I have for a and b, I'm just going to write out the general formula in terms of that. So Tn is equal to an squared plus bn plus c. I'm going to replace a and b with what I just calculated. And now we are going to use that first bit of information that was given, where they said term 29 is equal to 1164. So in this general formula, we are going to substitute. On the left hand side, I'm going to substitute 1164. And on the right hand side, wherever I have n, I am going to replace it with 29. Okay, so doing so, here is what I have, and you guys notice that there is only one unknown in this equation, which is c, so this is going to allow us to solve for c. So let's keep the left hand side as is. Simplifying the right hand side, that gives me 1102 plus C. Taking that 1102 over to the left, we get C as negative 938. Now that will allow you to write a complete general formula, which is going to be Tn is equal to 3 over 2 n squared minus 11 over 2n minus 938. And now we can finally answer the question which asked us to get the first term of this quadratic pattern. So we are going to replace n with 1. And let's just put this on the calculator. That should give us negative 942. So that is the first term of the quadratic pattern. And we are done with this question.